All right, now I'm going to get started solving nonlinear systems. Okay, nonlinear. All right, what makes it nonlinear in this case is here we got an exponent of 2 on that variable. But we're still just asked to solve this. And so we're still looking for ordered pairs that satisfy both equations at the same time. Okay, so we're going to use a lot of the techniques that we learned by solving linear ones. Okay, one of the things we're going to do is maybe since the second equation already has the y on a side by itself, maybe what we'll do is substitution. So we'll take this x squared plus 6x plus 7, which equals y, and we can plug it in for the y in the first equation because we're looking for ordered pairs that satisfy both. So at that point of intersection, these y's should be the same. And then if these y's are the same and y and all of that's the same, we ought to be able to put the x squared plus 6x plus 7 in place of the y in the first equation. Okay. All right, so now once I've done that, now I'm looking at how this equation has a squared in it. So I got in my mind from here on that I'm going to be working on solving a quadratic equation. So I'm going to combine these like terms and say x squared plus 8x plus 7 and equals -5. And I need the 0 equal to 0 to happen, whether I'm factoring or using the quadratic formula. So let me add 5 to both sides. And then I get to x squared plus 8x plus 12 equals 0. Okay. All right. So now I'm going to give factoring a try. Most of these are going to factor, by the way. So you ought to give it a shot. And I think if I use an x plus 6 and an x plus 2, that's going to work out pretty well. I can I double checked it. I just should have explained that. I double checked that factoring was correct by FOILing it out. And then once I'm sure it's right, I'm going to go ahead and just work out these two equations. All right, so I wind up with x equaling -6. Over here, I subtract 2, and I get x equaling -2. Okay, now here's the thing. This is a system that has 2 variables. I don't want these are both x's. I don't put them together as an ordered pair. They're both x's. So what I need to do now from here to the end is like a third part of the whole process. So it's like getting to here is one part, okay? And getting to here is another part. And then here at the end, I'm looking for the y's. So I'm thinking to myself here, I need the y. I need the y's, okay? So I'm going to go back up and take one of these 2 equations. You can take either one. Say we take the first one. Okay. I'm going to wind up taking and plugging in this -6 right here for the x. And then I'm going to do that same equation, but I'm going to put the -2 for the x. Okay. So here I'm going to have 2 with the -6 in here, and then plus the y equaling -5. Then over here, I'm going to have 2 with the -2 in there, plus the y equals -5. So I'm just going to work on solving each of these, see what I get, okay? So here I'd get a -12 plus y. So I'm going to add 12 to both sides to get the y by itself. And I'm going to wind up with y equaling 7. All right, and then over here, I'm going to get -4 plus y. I'm going to add 4 to both sides. When I do that, I wind up with the y equaling a -1. Okay, so this -6 that I had for x went with that 7 I got for the y. So that gives me one ordered pair. And then this -2 got matched up with that -1. And that gives me the other ordered pair. So I have 2 solutions on this, which is weird. You didn't have that on the others. And my math lab says something like the solution set is, and it gives you the set braces like that, and then has you put the points in it. Okay. So when you're doing something with a paper and pencil quiz, it's okay if you just circle the 2 points for me, not circle all 4 little pieces, but put it together as an ordered pair and circle those points. All right, I want to give you a sense as to why that happens. We're going to review graphing as our next topic. We just haven't done that yet. So if I back up a little bit and take a look at this one, you don't know this necessarily right now, but that second equation turns out to be a parabola. All right, and it would be a parabola. I'm not sure exactly what it would look like, but it might do something like this. Okay. I'm not even going to put the axis on there. That way I don't have to specify. Second one's going to be a parabola that opens up. I know that for a fact. And that line is going to be a line with a negative slope, looking something like that. Here's why you got 2 points. Okay. You got that one of them was the ordered pair -6, +7. That's this guy. And then the other point of intersection turned out to be the -2, -1. Okay. And those were your 2 ordered pairs. Okay. So you didn't need to know what it looked like. The algebra will take you to the end result just fine. But I thought if you had a sense of what was going on, it might help you. Okay. All right. So let's try another one. All right. This one has a situation, and what's going on here is that the first equation is really a circle, and the second equation is a line that may do something like that, and so we might have 2 points of intersection on this one, okay? So what we might do here is get one of the equations, one of the variables on a side by itself, and I would definitely use the second equation since either x or y we could work on getting by itself. Let me do the x because I think that's what I've been doing with you in class if you watched class. So if I want to get x by itself, I'd have to subtract the y from both sides. All right, now when you do that, you wind up with excuse me, wind up with the x equaling -y minus 7. All right, so what we're going to wind up doing, that's still the second equation, just rearranged, okay? What I'm going to wind up doing is thinking about the first equation that we had, and now the second equation in its new form, okay, kind of just is now looking a whole lot like the previous problem that we did. I'm looking for the intersection between the two. So the x from one equation, the x from the other would be the same at that point of intersection. And then the -y minus 7 is equal to x. So I ought to be able to put an x right in there. All right, so here's what we would get if we did that. We'd get that -y minus 7, and it would get squared, still with the plus y squared equaling the 25. The only difference would be right here where x was supposed to be, I put the -y minus 7. Okay. Now that -y minus 7 squared, if you haven't been in an algebra class in a while, you might mess that up. Okay. That is not equal to, it's not y squared plus 49. You don't just square each piece. What you should do, let me get rid of that so it doesn't look like a negative. What you should do is write it twice. That's what the squared means. That's what the exponent means. And then you FOIL it out. -y times -y would be positive y squared. -y times -7 would be positive 7y. So we did these two. Now we're going to come back and distribute the -7. And -7 times -y is again positive 7y. And then we have -7 times itself. So we get a positive 49. And then these are like terms that can be combined. So we have a middle term, you see. Okay, we have y squared plus 14y plus 49. So let's bring that in over here. Don't forget, you still have a plus y squared and the equal to 25. Right, so at this point, I'm going to go ahead and combine my like terms. I've got the y squared plus the y squared. We had a good discussion about this in class. Y squared plus y squared is just 2y squared. There's 2 y squareds. They're just like terms. The exponent doesn't change. If it were y squared times y squared, that's when it would become a y to the 4th. But that's not what's going on here, okay? So we wound up having 2y squared plus 14y. Let's go ahead and move that 25 while we're at it, because we need to get it equal to 0. So let's go ahead and do that while we're at it. And then let's kind of see where we're at and what we need to do. So I have a quadratic. All right. Oh, I noticed that 2 goes into all 3 of these. So I could, when I factor, when you do factoring, you're supposed to factor out the GCF. It's just oftentimes there's not one. Then factor. Okay. And so this does have a greatest common factor. We could take out the 2 from all the terms. We get y squared plus 7y plus 12 equals 0. That helps us get the factoring done a little more quickly because there's an understood 1 there in front of the y squared. So I'm going to factor that into y plus 3, y plus 4. Okay. And then I'm thinking, all right, this time I have 3 things, 3 quantities multiplied to be 0. So either the 2 has to be 0, the y plus 3 would have to be, or the y plus 4 would have to be equal to 0, right? So that's kind of what's going on. Well, 2 is 2. It can't turn into 0. There's not a variable with it. So you don't get a solution from there. But we do wind up with y equaling -3 or y equaling a -4. All right, now you've already done a ton of work, so you might think you're done. But remember, you don't just want y's. You need the x's that go with those. Okay, so we still have more work to do. I'm going to need a little more room. Let me see if I can get it to give me a couple. Yeah, there we go. All right, so I got to go back and take one of the equations in the beginning that had the x in it, and I think I won't go all the way back. Let's go to that equation 2 that we modified. Remember how it was x equals -y minus 7? Okay, because right now we need to find the x's. So we're going to take that equation. We're going to plug in the -3. And be careful when you do this, because there's a negative out in front and then minus the 7. So we're getting, on this one, we're getting that x equals 3 minus 7, which is -4. Over here, when we plug in the -4, we get something kind of similar. Let me bring that x all the way down. We get 4 minus 7, which gives us a -3. And then remember, you match them up. So these two go together and create one solution. Okay. And then these two go together to create the other solution. And look, I noticed that they are switched around, but that doesn't always happen. So don't assume that that's going to be the case. Okay, so these two went together, and then this one went with that one, and they just happen to be the same ordered pair flipped around. Okay. It doesn't always work that way, so don't draw too big of a conclusion there. All right, I'm going to have to start class in a minute, so let's stop here. That's kind of a good intro to solving nonlinear systems, and then we'll pick up from there, and I'll do a couple more in another video.